the last months we did a lot of work to the pump station. The last time we were here, you could still see that the whole backfilling had to be done. What you see now is 8 pumps being installed, and on the left side there's still space for 3 extra pumps. In case the terminal is being increased to a capacity of 16 BCMA, we can still add 3 pumps. What you see here is a black steel structure. Those are the filters. We have different layers of filters behind each other, going from coarse to fine. The finest mesh size is up to 0.5 millimeters, which is very, very small. This is just to avoid any debris or unwanted objects going into the pumps, into the warm water line. This is being cleaned by a backwashing system, completely automated. You're now looking at the seawater pumps. A pump consists out of 2 parts. The upper part is the motor part, the light part. The lower part is the grey part, which is the pump itself. It's a centrifugal single-stage pump, electrical driven, and the part is about 9 meters long. It goes into the water basin, collects the water, and in total 60,000 cubic meters of water per hour will go into the warm water line. And where you now see there the flange connection, it will be connected to the main header. The header is of GRP material and is actually the beginning of the warm water line. What you see here is the warm water line going underneath the railway. What you see, the railway has to be operational, so we had to be very sure that we didn't have any vibrations or settlements of the railway itself. The technique that's being used here is called horizontal directional drilling, and it's a very common technique which we already used once before at Lyondell area, where we crossed into the public road, crossed back into the E.ON area, and eventually this will be connected to the header, which is connected to the pump station. On one side you see the E.ON water basin with the relatively warm water. That water will be pumped by the 8 installed pumps to the header connection, where you see all the pipes going into the header. That water will come to this side where you see the 2 holes, and those are the holes where the water line is being connected. So the GRP lines in the coming months are going to be connected to the header. We're now standing at the south shaft of the microtunnel. The microtunnel is actually the tunnel going from this side to the gate terminal sites. It's part of the warm water line. It's called microtunnel, but that's technique. It's not so small. The tunnel itself has a diameter of 2.2 inner diameter, and it started on the other side. The other side also has a shaft like this one, which contains sheet piles. The other side is 9 meters deep. This one is 22.5 meters deep. And what they did is they started on the other side with a tunnel bore machine, TBM. It took the machine about 3 months to go from that side to this side. It's about 1,069 meters to be precise. And after the tunnel bore, the segments of the tunnel were lifted into the shaft, and 3.3 meters segments were being pushed hydraulically behind the TBM. The tunnel itself contains out of a core which is made of steel and concrete on the inner and outer side to protect the tunnel. The depth of the tunnel is 30 meters deep, which is quite deep. This is being done because the port still wants to be able to dig out the port deeper if needed in the future. So it can be dug up to 24 meters. On this side, the tunnel bore machine was taken out, and eventually this will be the connection to the warm water line.